we need to send the traffic to router, okay, and after that router can find the best path and forward the traffic to the destination networks. The first question is that when a PC1, assume that here we have PC1 and also PC1 needs to send a traffic to one destination IP, okay? PC1, if understand that the traffic should go inside of the network, the PC1 does not need to send the traffic to the router. But if the PC1 understands that destination is residing outside of its networks, it needs to forward the traffic to the router of network. For example, assume that here the PC1 address, okay, this is the PC1 address is quad 1, and the destination IP is 1112, okay? Because until now we didn't know about the network part of the PC1 and the destination IP, okay? PC1 doesn't know about that this address is residing in the same network of PC1 or in another networks. Because of that, PC1 doesn't know that it should forward the traffic directly to PC2 from a switch, or it should forward the traffic from PC1 to the router, okay? Here we have a question. We need this, we need the information about the network ID to find the solution to the answer of this question. If the PC1 knows that, for example, which part of these addresses are the network ID, the PC1 can compare the network ID of its IP address and the destination IP address and find the answer of this question, that the traffic should forward directly to PC2 with a switch, for example, or should forward to router, after that forward the traffic to the destination. Because of that, this is so important for PC1 to understand the network IDs of the one IP address, and after that it can use the network ID of its IP address and the network ID of the destination IP address. If these two network ID are same, the traffic can forward directly from PC1 to PC2, and if the network ID are different, the traffic can forward to the router to forwarding. Because of that, the first and very often one of the most important question about the IP address, one IP address, is that which part of one IP address, okay, is network ID and which part of IP address is host ID. Why we need this, the answer of this question? Because according to the answer of this question, PC1 or any devices can forward the traffic directly to the destination, or can use this information for sending the traffic to the router for finally forwarding traffic outside of the network. How we can find the different parts of the one IP address? We have some rules, IP address classes rules, okay, IP address classes rules, that we can use these rules to finding the network ID and also the host ID of the one IP address. Let me to talk about these rules. This is so important for understanding the IP address functionality. We will use these rules in many scenarios and in many other features. Let me to talk about the IP address classes rules. Each IP address, okay, let me to write here, each IP address is residing in one class. I will talk about that class. For example, we have class A, class B, class C, class D, and also class E, okay? We have these classes. Each IP address is residing in one of the class A, class B, class C, and class D, and also class E. One of the class A, B, C, D, or E is the class of one IP address, okay? And after that, maybe you ask me, what is the class of IP address and how we can find the class of IP address? Look at here, you know that in one IP address, we have 4 octets. Look at here, this is one IP address, x.1. For example, .y.z.w. Okay, this is the IP address. Okay, and this IP address, as you can see, has 4 octets. The octet, for example, 1, octet 2, octet 3, okay, and octet 4. Okay, the class of IP address is only relevant to the octet 1, the X. Okay, if you want to find the class of IP address, you need to only think about the X or octet 1. You know that in each of the octets, we have a value between 0 to 255, 255, and because of that, only the octet 1 is relevant to the, for example, the classes or IP address classes. Let me to talk about the IP address classes. You know that in each octet we have 8 bits, XXXX, XXXX. Okay, this is the first 8 bits of the, for example, first octet, and after that also we have another part. I'm not going to talk about the other octets, but the other octets are not relevant to our scenario. Only we are talking about this first octet and this first 8 bits. Okay. The first rule, let me to use this first rule. We have some IP addresses in class A. All of the addresses of class A is starting with the first 0 bits. This means that this bit is 0, okay? And let me write here, if the first X bit is 0, that IP address is residing in class A. Let me write here, this is class A, okay? And after that, the other bits is not important. For example, you know that for other bits, we can have 70, this is the minimum value, and also we can have 71, the maximum value. This means that when you have in decimal, when you have a value between 0 to 127, that IP address is residing in class A. Okay, you will learn about the class A information, but let me to say that if you have one IP address with this value between 0 to 127 in the first octet, okay, this is the address of class A. I will give you many examples about this. For example, if you have this IP address 100.111, it's not important that what is the value of the octet 2, octet 3, or octet 4. Only the value of octet 1 is important. 100 is between 0 to 127. Or for example, 100.01, 255, 254, 255. Again, this is the class A address. Okay, you will learn about the detail of class A, but for now you have one new information. If one IP address is starting with the bit 0, that IP address is residing in class A. After that, we have the class B. In class B, okay, when one IP address started with 1, okay, and continued with the 0 bits, that is the class B. Look at here, as you know, let me to write here, it's give you more information to you. Look at here, 1, 0. If one IP address starts with 1, 0, that is the class B. You know that we say that the IP addressing started with 0 is the member of class A, and if the IP address is starting with 1 and half of that 1 started IP addressing now is residing in class B. Okay, you know that if we use all of the 1 started bits, we finished all of the IP address, but again I have the IP addresses of the started with 1 to 2 parts. 1 continued with 0, and after that I will talk about the 1 continued with the 1 again. Okay, because of that, when one IP address started with 1, 0, this is the IP, this is the member of class B. This is the rule. Okay, you know to learn about this also. And after that, we can use quad 6 as the minimum value. After that, this 1, 0, and after that, for example, quad 1, both minimum and maximum value. If you calculate the 1, 0 against 6 zeros, you will have 128 as the minimum value. And if you want to calculate this value, you will have 191. Okay, it's so important because look at here, if we use all of the bits 251, this is equal to 255, but you need to subtract 64 from the 255, the result is 191. Okay, after that, now you learn about the class B. If the first octet of one IP address is residing between 128 and 191, that IP address is residing in the class B. Okay, let me to continue. After that, we have class C. Okay, the class C's addresses is starting with the 110. Okay, 110. This means that, let me to give you another information here. You know that 0 started IP addressing is residing class A, 10 class B. Now 1 1 again part of the 1